Welcome back, class. We're now on page 43, and we're going to learn how to rotate about axes that are not x or y axis. We're still going to be using disk washer. We are in section 7.2, and I think we did this first one in class, so let's remind ourselves how it went. So what we're going to do is we're going to take the region between y equals x and y equals x squared, rotate about the line y equals 2. Now, y equals 2 is a horizontal line. So we need everything in terms of x. When we look over here, and yeah, we have y as a function of x, y as a function of x. So I think we're good on the functions. We don't need to modify them in any way, shape, or form. So what we're going to do is we're going to draw the picture here. So let's say here's one, and here's one here, and we'll just list off. There's two. That'll be our axis, so just give that a minute before it shows up. All right. So the line y equals x is a straight line from 0 to 1, like this. And then x squared, as we know, starts beneath it, like so. And we're going to rotate here about the line y equals 2. All right, so what that gets us now, if you look, when you rotate this, this point here, this topmost point of the function, is still 1 unit away from our axis. So when you rotate it about this axis, that's not going to change. I think in class I made some kind of analogy about like a pivot foot in basketball. So think about that. And now it looks like when we rotate it, the x squared part will be on the outside of the thing that we get. So let's see if I can, well, I should have used red to draw that, but let's see if I can use red here to draw the cross-sectional washer that we're going to get. So when we spin it, we get something like this. So here's our outer, and then here, like so. Okay, so our cross-sectional area will be a function of x. We're using a horizontal axis, so everything is going to be in terms of x. We get pi times bracket outer radius squared minus inner radius squared. Okay. All right, so let's fill in, let's see if we can fill in what the outer radius is first. So what we're going to do is we're going to pick a x value here in 0 to 1, and we need this length here. And like I said, it kind of involves the x squared function, but it's not x squared just itself. It's going to be, in this case, this length is 2 minus x squared. Notice as I move x a little bit farther to the right, my outer radius gets a bit smaller, so I'm subtracting values, right? So it's going to be 2 minus, and now I always like to put parentheses. I think we saw that on the last homework. It's maybe good to put parentheses around the function that we're subtracting. Okay, and now using green, let's find what our inner radius is. Well, it's going to be now involving this function y equals x, but instead of subtracting x squared, we're just subtracting x here. So I think it'll be 2 minus x. So we get 2 minus x. Okay, and we're going to simplify. So this is pi, and we're going to need a little bit of room here. So square 2 minus x squared, and you get, I think, 4 minus 4x squared plus x to the 4. And now square 2 minus x, and I think we're going to get 4 minus 4x plus x squared. And to simplify this, let's see here, we're going to get pi bracket. We get 4 minus 4, so those are going to cancel. We get minus 4x squared minus 1x squared, so I think that'll be minus 5x squared. We get x to the 4th and nothing else, no other x to the 4th, so that'll stay as is. And we get a minus negative 4x, which will turn into a plus 4x. So now this is our area function. So to find the volume of this, albeit strained solid, we're going to integrate a of x dx. So we integrate x bounds of the region, so 0 to 1, and our a of x function here is pi times bracket minus 5x squared plus x to the 4 plus 4x. And if we do an integration here, I think what we're going to get is pi, let's see, we increase the power by 1, divide by the new power, so that's minus 5/3 x cubed plus x to the 5th over 5 plus 2x squared. And what that gives us is plug in 1, so we get pi times parentheses minus 5 over 3, 1 cubed plus 1 to the 5th over 5 plus 2 times 1 squared. And now I think if we plug in 0, we can all agree that all of that is going to go away. And so our common denominator is going to be 15, so we get pi times parentheses, let's see, so we would need to multiply this denominator by 5, so we're going to do the same to the top, and I think we're going to get minus 25. This one we're going to multiply by 3, and this one we would need to multiply by 15, so I think we're going to get plus 30. And adding all that up and simplifying, it looks like we're going to get 8 pi over 15, which, if I'm not mistaken, is what we got in class. Okay, so now let's rotate the same region. So I'm going to redraw the picture. Let's rotate the same region, but now about the line x equals minus 1, which you'll notice is a vertical axis. So we'll get to that in a minute. So just redrawing the region, here I have y equals x squared. Here's where they meet. Okay, now this is a vertical line. So here's x equals -1. So I get this thing here, and I'm going to spin about this. So because this is a vertical line and I'm in section 7.2, I need to convert my functions over to functions of y. So my first function was y equals x. Well, I can just rewrite that as x equals y. Okay, that one's done. My other one was y equals x squared. Well, that is just x equals the square root of y, which I'm going to rewrite as y to the 1/2. All right, now I'm going to need the vertical y bounds of the region. Well, those are still 0 to 1, thankfully, for this problem, because they meet at y equals 0 and also at y equals 1. All right, so to get a picture of what this looks like now, you'll notice when I spin, I still have this gap of 1 here, and that's important. So this will be my nearest point, and then it kind of goes like this, and now the parabola forms the bottom part. We're just going to get a bowl with a, I guess, big hole in the middle. Here's going to be our inner part of the washer, and this here is going to be our outer part of the washer. All right, so our area function now, class, is going to be a of y, pi, bracket, outer radius squared, minus inner radius squared. All right, so this is where things get a little bit interesting. So let's try to determine our outer radius. So let's pick a y value in our range here, our y range. I need to know this length, right? That length there. Well, let's break this into two halves here. So first of which is the half that we know, right? From the actual y-axis to this point here on the outer, I guess, curve y equals, or x equals 1, y to the 1/2. That is just the function y to the 1/2. but I'm always adding 1. Notice I'm always having this buffer of 1 unit here. So in fact, this outer radius will be y to the 1/2 plus that persistent buffer of 1. And similarly, if I now need to know, let's turn this over to green, this inner radius here, well, that's going to be this function of y, x equals y, but now I have this persistent buffer of a length 1 here. Okay. And so simplifying, what I get is I get pi times bracket, let's see, y plus 2y to the 1/2 plus 1 minus parentheses y squared plus 2y plus 1. And I can simplify this. This is pi. I get y minus 2y is minus y. There's no other y to the 1/2, so I get plus 2y to the 1/2. I get a 1 minus a 1 is 0, and I get a minus y squared. All right. So now what we're going to do to find the volume is we're going to integrate, but now on the y bounds of the region. So this is still 0 to 1, but for a different reason, right? It's the y bounds of the region. Okay, and a of y dy, so minus y plus 2y to the 1/2 minus y squared dy. And this antiderivative, the only tricky part about it is the fact that we need to increase the power here. So the new power is y to the 3/2. And then we need to divide by 3/2, which is the same as multiplying by 2/3. But I already have a factor of 2 there, so I think I'm going to get plus 2 times 2/3. Okay. We can see that that's 4/3. And so what we're going to get here is we plug in 1, we get minus 1 squared over 2 plus 4/3 times 1 to the 3/2. Whoops. 3/2, not scribble half. And then minus 1 cubed. I did it again. 1 cubed over 3. Okay. And now if we plug in 0, I'm just going to quickly talk through this. That's 0. 0 to the 3/2 is 0. And 0 cubed is also 0. So all of that's 0. It's nice when it works out that way. Okay. So this is minus 1/2 plus 4/3. 1 to any power is just itself class. And now minus 1/3. And we can quickly do this. 4/3 minus 1/3 is 3/3, also known as 1, minus another half is 1/2. So I get pi times 1/2, better known as pi over 2. All right, in the next video, we'll be covering page 44, where we're going to do a few more of these problems. And that'll be the end then of section 7.2.